Hello everyone, my name is Anil Poddar. So today I am going to discuss about unit number 4, input output organization, lecture number 26. So the contents we are going to discuss in this video is about interface circuits and parallel and serial ports. So let's see what is interface circuits. Now an input output interface consists of circuitry required to connect an input output devices to a computer bus. So the definition of input output interface is, so it consists of a circuit that is required to connect only input output devices to a computer bus. So on one side of the interface there is a bus signals for address, data and control. On the other side, there is a data path with its associated controls to transfer data between interface and input output devices. So there are two sides. So on one side of the interface there is a bus signals for address, data and control. On the other side there is a data path that is for transferring the data between interface and input output devices. This side is called as a port. So the second side is called as port. It can be classified as a parallel or serial port. So parallel port transfer the data in the form of number of bits, typically 8 or 16. So the data part, that is the transfer data part, is called as a port, simultaneously or from data. A serial port transmits and receives one bit at a time. That is, communication with the bus is same for both the formats. The conversion from parallel to serial format and one takes place inside the interface circuit only. Now first one we will go for the parallel port. So in the diagram you can see it consists of a parallel port. A typical keyboard consists of mechanical switches that are normally open. Okay, so when you press a key or serial in, its switch closes and establishes a path for an electrical signal. Okay, so suppose if you have a keyboard switch, as you can see in the diagram, so meaning one of the key, if you press, its switch closes and establishes a path for an electrical signal. Now after generating the signal, it is detected by an encoder circuit. So what is encoder circuit will do is, it will generate an ASCII code for the corresponding character. Suppose if you have typed a character called as A on the keyboard, so for that it will generate a signal and also it will generate an ASCII code for that A character. Debouncing circuits are included as a part of encoder block. Now whatever the ASCII code are generated for a character, that is the output of the encoder. It will consist of the bits that represent the encoded character and one control signal called valid, it which indicates that a key has been pressed. What it means is, whenever a key is pressed, one of the keys pressed, it will generate a signal as well as it will generate an ASCII code. So that ASCII code, okay, will be of the corresponding character. Now after the generating ASCII character, the output of the encoder will be consist of the bits that will represent that encoded, that is encoded ASCII code character, as well as one more it generates, that is valid control signal. So valid control signal indicates that the key has been pressed. Okay, so these are the two outputs given by the encoder after pressing the one of the keys. Now after this information, whatever the data as well as the data that contains the encoded character as well as the valid key is sent to the interface circuit, which contains a data register called as data in and status flag serial. As you can see in the diagram, there is a interface circuit, so it contains two registers, data in and status flag sin. So when a key is pressed, valid signal changes from 0 to 1, means the key has been pressed, which causes the ASCII code to be loaded in data in. So whatever the output from encoder, that is ASCII code character as well as the valid signal, ASCII code will be loaded into data in and assign will be set to 1. Okay, now the status flag assign is cleared to 0 when the processor reads the contents of data in register. So whenever flag in is cleared to 0, only when the processor reads the contents of data in register. So once it read is, again it is cleared to 0. Now if you again press the key, okay, if you again press the key, valid signal will changes, again it changes from 0 to 1. Okay, then ASCII character will be loaded into the data in and assign will be set to 1. We press another key. Now once the processor reads the contents of the data in register, so whatever the key you have pressed, when it receives, again the flag SIN is cleared to 0. Again the processor repeats. If you processor repeats again, if you press another key, valid signal will changes from 0 to 1. Again ASCII code, whatever the ASCII code generated character will be loaded again into the data in, and SIN will be set to 1. Now when processor reads the data, again a flag SIN will be created to 0, which means the contents have been read. The interface circuit is connected to a asynchronous bus. Okay, the third control line distinguishes read and write transfer. As you can see here, the third line it requests whether it is a read or write operation. So last slide we have seen about parallel port. Now we'll go to serial port. The serial port is used to connect the processors to input-output devices that require transfer of data 1 bit at a time. So data is transferred only 1 bit at a time. The interface circuit for a serial port is capable of communicating a bit serial fashion on device side and a bit parallel fashion on bus side. Now the transformation between parallel and serial are achieved with shift registers that have parallel access capability. So this is the serial port, as you can see here. Here it includes data in and data out registers. First, the input shift register. First, the input shift register accepts bit serial input from the input output device. So when all 8 bits of data as you can see here, it includes data in data out registers. So the input shift register accepts bit serial input from the input output devices. Now when all 8 bits of data have been received, that is 1 byte of data has been received, the contents of the shift register are loaded into the parallelly into the data in register. Similarly, output data of the data out register are loaded into the output shift register, from which the bits are shifted out and sent to the output device. So this is how input output transfer takes place in serial registers. Now the SIN flag is set to 1 when new data is loaded into the data in. It's same as that of the parallel port. Now it is clear to 0 only when the processor reads the contents of data in. Now when data is transferred from input shift register into the data in register, so the shift register can start accepting the next 8-bit characters, which means suppose when you are transferring the data is transferred from input register to the data in register, so already the data has been transferred, so it can be get ready to accept the next 8-bit characters or next 8-bit character from the input output device. Now the SO out flag indicates whether the output buffer is available or not. Now SO out is cleared to 0 only when the processor writes new data into the data out register. Okay, and is set to 1 when data is transferred from data output to the output shift register, which means it will be 0 when processor will write a new data into the data register, and it will set to 1 when data is transferred from data out to the output shift register. Now in this video we have discussed about what is an interface circuits, working of serial and parallel ports. Thank you.